Hi, welcome. I would like to go over Python from the lens of a person who knows Java. And we're really covering sort of the introductory syntax that you need to just get Python working for you if you're coming from the perspective of a Java developer or you've been programming in Java and you want to see what the Python equivalents are, then this is a good video for you. In Java, if you've programmed in Java, you know that you have some boilerplate code, and if you're familiar with object-oriented programming, you'll know what this boilerplate code is on the right-hand side. It's basically just a class within which we have our public static void main. We need that, and we know that if we want to do the most basic thing in Java, let's say to print something out, we can quite literally put our print line command that we're all familiar with. Now in Python, it's slightly different. There's no boilerplate code. And the command for printing something out is quite simply just printing something out. And of course, we can omit the semicolon. So that's another syntactic detail that if you're working in Python and you want to print something out, you can quite literally just do print, and then whatever it is you want to print out, then you can omit the semicolons. We don't need semicolons in Python, although we can have them and still have our program run. That's sort of the first detail. And of course, in Java, we know that as far as data types are concerned, we can have, an integer variable, a double, which would basically hold, floating point numbers, and we can have string, which could perhaps hold, a name, and each of these have to have a semicolon, and we could have a Boolean, let's say a verdict, and that could either be true or it could either be false. Now, when we introduce data types in Python, it's a little different because we don't have to write down what the data type is. Of course, Python supports all of these varying different data types, but again, we don't have to write the data type. We can simply write the name of the variable. So we could say, we could say x is equal to 5. We could say y is equal to 2.2. And again, we don't need the semicolon. And we could say, name is Jacob. And again, we don't need to preface our variable names by the data type that they are. And we could have even a Boolean, right? So we could say this is our verdict. And here, instead of saying true lowercase or false lowercase, you want to actually capitalize that first letter. So just say true or just say false. Either works. But you just want to make sure that first character there is in fact capitalized. And so these are the equivalents, right? And you can see that if I wanted to print them out, I could say, okay, well, what is X? And then, I'll sort of have this run here. And you'll see that if I do this, okay, I don't want to debug, obviously. And so I'm stuck in debug mode for now. But if I run the program, I get high because of the high I had up here. And then, of course, I have my X down below, which is 5. And of course, I can do this for, verdict as well. And, everything is still as fine as it was before, in which case this is false. So those are the associated data types. We don't have to declare them. Python works on something called type inference, which is where it infers the type based on the data type of the variable you basically claim. So if I claim that this is an integer, if X is an integer, all I have to do is assign it 5, and it will infer what the type is just by me giving it an integer. It'll know it's an integer. And so that's really the main idea there for data types. Let's look at some operations you can do, right? So we know that in Java, if we wanted to add two things together, we could basically just do, we could create a result variable, and of course we have to be consistent with what we're using in terms of a data type. We can do x plus y, and then we can essentially print that result out, right? Now in Python, you still have your x, right? You still have your y, and then we introduce a result variable and we just say x plus y. So right down the line, it's very simple. And then we can essentially print our result. Now, something interesting is going to happen here. You'll see I get 15 much in the same way I got 15 in Java. And results, it basically goes through this type inference chain where it looks at x, it sees it's an integer, it looks at y, it sees it's an integer. And then so it infers that result 2 must be an integer. So these are sort of the equivalents. And of course, We're more than welcome to do, subtraction. We're more than welcome to do addition. Of course, both of these work across the board. Multiplication works in much the same way you'd expect in Java. Division works in again, much the same way you'd expect in Java, right? So you'd multiply in this case, or really divide. We might see that Java, we might see that Java it will tend to truncate for you. So, but truncate means it basically takes away numbers after the decimal point. In this case, it truncates the 5, it just keeps the 0. So again, a slight difference in behavior in terms of that there, but not much beyond that, right? So we've covered sort of the basics in terms of the data types and so forth. Let's take a brief look at the scanner. So we know that if in Java you wanted to create a scanner, you would introduce a scanner, you'd say my scanner equals new scanner, and then you'd pass in a command, it would be system.in, then you'd end that with a semicolon. And of course, you'll be sort of flagged with an error, and the error is that you have to import the class that correlates with the scanner for you to use it. And then you can say, okay, well, you can prompt the user, right? And again, that's true for Python too, prompting. You can prompt the user, you can say enter a number. And the idea here would be to say, okay, well, I'll create a string variable. I'll create a name for the string I want. Let's say this is num1. And then I can say, the name of my scanner dot, and again, this is not going to be a string. It's in fact going to be an integer because we're talking about numbers here. And then it will be it would be next line for string, next double for doubles. And so that's really the idea here, right? So you can see that this is interactive. I can print out, I haven't actually printed out 5, but I can if I wanted to. I could say print line and then num1. And so that's true for Java, and it works much in the same way in Python, except it's very simplified. So I can just create num1. I can say that, well, this is num1 for me, and I'm not going to type. I'm going to let Python do its type inference thing. It'll infer what we get. You'll use a command called input, and then you'll have 2 parentheses here. And then the prompt that you want to ask them, you can essentially put in the brackets. So you can say, enter a number, right? Enter a number. And what's going to happen is that, so this is ideal, right? You introduced a number, you used the input command, and then your prompt essentially said, okay, we'll enter a number. And then whatever happens as a result of that will be stored in num1. Now, something interesting might happen once we walk down the road a bit. So we entered a number, we said it was 4, we got 4 back. Now, in Python, and again, I'm not going to do the equivalent in Java because we've already covered that, but if you introduce, let's say, X and Y, and then you said, okay, well, let's not introduce X and Y just yet. So let me say num1 is such and num2 is input, and then I'll say enter enter a number again, or enter I'll say enter num2, and for the first one I'll say enter num1, right? Now the interesting thing is I can introduce a result variable here, result, and then I'll say num1 plus num2. And then I'll just go ahead and print out result. Now you'll see that I might get 2 different answers if I do this in Java and Python, right? I could say here enter enter num1, and then I could repeat this process once more. I'll just duplicate it right underneath, and I'll just say enter num2, and I'll store that in num2, and then result will essentially store the addition of num1 plus num2. Just in the way that we think, and then we'll print out results. So I'm going to print both of these out, and you'll see that we might get varying answers. So if I enter, let's say 10 and 12, you can see I get 10, 12, right? Here, if I were to do that process, if I were to enter 10 and 12, I get 22, which is what I expect. So what happened in Python here? What happens in Python is that the input, right? So whatever you input, it will actually store that in num1 as a string. So it's going to store it as a string initially. So when I put num1 in and I pass in, let's say in this case I passed in 10, input basically will store a string of 10 into num1, And then when I do the same thing with num2, it again produces a string and stores it in num2. And then when I do an add operation, it doesn't actually add the numbers themselves, but it adds it concatenates them. It concatenates them. So much in the same way I can say, much in the same way I can say first name equals Jacob and last name equals White. Once I print this out, once I say first name plus, and then maybe a gap between them, right? Plus last name. This is a concatenated string, right? And you can see that if I do this, first name plus last name. So if I do this here, I get Jacob White. So it's concatenating the strings, right? And I could have done that without the space, but it would have been slightly awkward. I'm just demonstrating how you concatenate strings, right? You get Jacob White that's merged together. Nonetheless, so that process exists to concatenate strings, and that's exactly what happens in Python when we concatenate those strings. And so the input always returns a string, and then those strings end up being concatenated. So in order to combat that, we have to introduce something in Python called typecasting. And what typecasting does is it says, okay, well, take whatever you get from input, and if I write int and then I wrap the input in 2 brackets, it will actually take whatever input produces and it will make sure that it's an integer, or it will actually change it into an integer, right? And so I can essentially do that here. So I can say int, and then you can see I took both sets of inputs and I essentially typecasted them such that they are now ints from string. So it takes the string 5, let's say, and it's a string so far, and then it finds out what the integer equivalent is, and then it produces that and stores that in num1 and num2. So if I do this again, if I do this once more, you'll see if I do 5 and I do 10, I produce 15, and that's actually the same result I'd get if I had done that in Java, right? If I do 5 and I do 10, I get 15. So that's essentially the idea. Now, what if you wanted to present that in a manner that that would probably be a little more appealing? Let's say I wanted to print out result, right? So let's say I wanted to say, your sum is, so let's say I say, the sum of, and this is going to be sort of a tedious process, the sum of num1 plus, and then another space, and let's say and, right? And then I have to, again, do this num2, and then another plus, and then another space is, and then again another space at the end plus the result. So this is a problem, right? This is one of the tedious parts of Java, that it kind of makes you go through this process, but you eventually get it down. You say the sum of 5 and 10 is 15. But in our case in Python has a way of making this a little more interactive and a little more flexible, right? So it uses something called f-string. So what you essentially do is you say, okay, well, forget it. I'm going to put f, and then I'm going to put two parentheses, well, not parentheses, but quotations. And then within these quotations, you can say, well, the sum of, so using this f lets you do something very special. We'll talk about what that special thing is. It's that if you take 2 brackets and you can say, okay, well, you can put your variables here. You can say num1 plus, and then the sum of that and this num2 is, and then again, you can just say result. And you can see we didn't really do anything too complicated in that light, right? We said enter num1 10, enter num2 15, and then the sum of 10. The sum of 10 and the number we're concerned with, so 10 and 15, let's do that again, 10 and 15. Sum of 10 and 15 is 25. So it's clear from that much that using f-strings, and that's what they're called f-strings, is greatly beneficial in that you don't have to deal with all this concatenation stuff. What's happening under the hood is you're concatenating, but you don't necessarily have to if you don't want to. And again, you could in the same way we've done it in Java. In fact, I could probably take this entire thing here and present it over here, and I still would be fine, right? I still would be fine. I can say plus, I can say 10 and 15, and I'd still, so why won't I be fine? Okay, so it's learning moment, right? Why won't I be fine? I won't be fine because this print statement, inside a print statement, and this is a fact I probably overlooked, but inside a print statement, you can only have strings. So the only way this will work in a print statement is if you take each of these numbers, because by this time in the program, they're actual numbers. if you have to typecast them, so you do str and you wrap them in these brackets, and again you do str again and you wrap them in these brackets, and then again you do str again and you wrap them in these brackets. So you have to constantly do this wrapping behavior, and now everything works. So the two cardinal rules is that your input will always return a string first, and it's your job to take that into account and typecast it into an integer. And then the second fact is that your print statement will only allow you to have strings, and you have to do your due diligence to actually take those integers and typecast them into strings. It's a tedious process, but it is what it is. And of course, you could have avoided that. You could have avoided that if you had used f strings, right? So much in the same way what we had before, f strings don't have that problem, right? If you just do it with the f strings, you're in good shape. And so that's the idea. And I think if I add spaces here, this will give me a little flexibility in terms of how I write it, in that they won't be squished together. But you can see the benefit over Python, over Java, that is, that we have some way. This is called string interpolation in some other languages, but we have some way of avoiding this problem. Nonetheless, we'll move on to our next main topic, which in our case is loops. Or actually, let's go ahead and look at conditionals first. In the context of Java programming, we're probably aware, and I'm going to have some variables here that will just act as things that I can demonstrate conditionals with. So if x is equal to 10, I can essentially do something here. I have some operators, and I'll go ahead and note what those operators are. The operators here, and this is going to be what we use in conditionals. We can check if two things are equal by using the equals sign. We can check if something is greater than or equal to or less than or equal to or equal to or less than or greater than. All of these are valid, and these are generally most of the operators we use. But we have an or operator, like is this true or is this true, using these two pipe the sort of the pipe symbols here. And then we have an ampersand, which checks that both conditions must be true for us to return true for the condition. So these are generally the main cases here. Now we'll go ahead and see what we get with Python. So what are some of the Python equivalents? So we'll write sort of a print line here. So if x is equal to 10, which it is, we get a high here. And in this case, in the case of, and again, I'll sort of remove the num1 and num2. I'll just say num1 is, or I'll just say x is equal to 10 and y is equal to 20, just to keep things consistent in what we have on the right-hand side. I'll go ahead and say that if, and again, you don't need parentheses for your conditionals. So you can say if x is equal to 10, and then you have a semicolon. So this is the format, right? You say if, you drop the parentheses that you had in Java, you use the conditional that you want, and then you end with a semicolon instead of brackets. So Python won't actually have brackets, right? You won't have these brackets. It'll throw an error. You'll just have a colon, and then you can insert to the next line, and then you can write your logic. So if x is equal to 10, we can print out high, and again, this is a very simple type of arrangement, right? You can see how condensed this is relative to Java, which is slightly more verbose. So we're expecting high, and we get high. So those are sort of the key things to remember. Is in Java you have the parentheses, drop the parentheses, add the semicolon, and then when you want to write your code, or when you want to write your logic that relates to that if statement, make sure to take that code and actually indent it, right? Indent it. You can see that there is sort of a gap between really the left border of the IDE and the print statement. So that indentation is telling Python that your code related to the if statement is actually part of this umbrella if statement. And that's the idea. And I want to briefly cover what we have in terms of operators, or conditional operators. So we do have equal. That's clear. Let's go ahead and see what we get with or. So if we do, if in Python, if we were to do, if x is equal to 10, or y is equal to 20, print out high. And of course, we're expecting high as a result. But here, if x is equal to 10, if we do or here, there's a problem. And the problem is that Python does not support the or operator in the way we see it in Java. The or operator, the equivalent, is actually or itself, which kind of makes Python a little more friendly, right? And here, if x is equal to 10 and y is equal to 20, let's see if Python supports this and feature. And again, we're surprised at the fact it doesn't. But really, the idea is that it supports the word and. So you can see that Python, the philosophy of Python is not to make things needlessly complicated or abstracted away behind symbols if we don't need to. So and or, and we'll make a note of that. We'll say, and again, so the comment system, right? You can see in the comments, in Java at least, I have a dash followed by an asterisk, and then I have sort of an ending where I reverse that order. And that basically tells my IDE that I'm making a block of comments. In Python, the comments are actually a hashtag. So it's very simple. We don't have to really introduce new symbols here. We don't have to introduce a dash and an asterisk. We can just stick true with one dash, or not a dash, but a hashtag, or whatever, or a pound, whatever you want to call it. And so we covered the conditional operators, right? We said that all of these will work, right? So you'll still have all of these because those are the intuitive parts of everyday math that we're most familiar with. But the and % operator, namely, is the equivalent now is just and itself, and the or operator, which we saw in Java, was with the pipe type of style. Here we quite literally just have or. And so that's the idea. So let's go ahead and play with this for a bit. So in Java, you know that I can nest things, right? I can nest things. So I can say if x is equal to 10, do something. But I can also say here, if y is greater than 20, or actually let me say if y is let me say if y is equal to 20, I'll say system.out.print line, and I'll go ahead and print something, right? So I'm expecting something, right? I'm expecting something because this checks out, right? I first go into my first if, then my second, and since I've passed the conditional for both the first and second, I do in fact get something. This is called nested if statements. Let's see how that translates in Python. So I can say if x is equal to 10, and then I have my semicolon there instead of my brackets, and then I move to the next line. PyCharm will actually auto indent for me. I don't actually have to do that, but you can if you wanted to. You could turn that auto indent option off. Here in this case, at least, I can say I could just introduce another one. So I'm indenting and I start another if. So I say if y is equal to 20, print something, right? Or print something. So in that way we're safe, right? So clearly we get something as a result. And so those are essentially conditionals. Now we've only really covered if. There's also a few others, right? So we know that in Java, if something is true, we can do something else, otherwise, else if, right? Else if something else is true, and again, you have your parentheses to say what that is, right? If x is less than 10, right? Less than 10, then again, you have some logic to perform. Finally, this is sort of a catch-all that you present at the end. Else, finally, else, do some logic. So if this one doesn't check through and this one doesn't check through, finally, we're at the last. In Python, it's slightly different. So if we say if x is equal to 10, that part's fine. We perform some logic here. Else if is actually replaced with elif, right, which is sort of a shortened version of else if. And elif again, we provide logic for that, right? If x is greater than 10, Again, we'll have some logic here to execute. And then finally, else, do something at the end. So we'll say if it's equal, we'll just say it's equal. And again, I'm just going to take this line here and just bring it to the second. And I'll say greater than, and otherwise I'll just say, well, I'm in my catch-all, right? So this is my catch-all statement at the bottom. So I'll come back to Java here and I'll go ahead and repeat the same process where I'll say that it's equal in the first. I'll take that line, I'll bring it to the bottom, or I'll come to the second branch, that is. And in the third, I'll have my catch-all. So I'm replacing what I have in my last one with catch-all. And my second one will basically say greater than, so that I'm just on the same page as I am with Python. And of course, I get equal here and I get equal here. The world is a good place. So that's the idea with if, else if, and else, as you know it in Java. The equivalent of that is if, elif, else. And of course, if I wanted to, I could have nested if statements, right? So I could say, if x is, so it's less than 10, I know that. But if x is, I could say something like if x is greater than 5. So I'm just sort of doing a more detailed check. If x is greater than 5, and then print hello, right? And then everything works out. So that's the idea. This is the idea behind conditionals, and we'll go ahead and move on to the next topic, which I believe should probably be loops, right? So we're going to take a look at loops here. In Java, and this is true for Python too, we predominantly have a few loops, right? So we have a for loop, and this is for when we know how many times we want to iterate, right? And then of course we have a while loop, which is commonly used when we don't know how many times we want to iterate. And lastly, a do while loop is basically the same as a while, except when we want to execute at least once, that's essentially what we use, right? So we'll look at them on a case-by-case basis. We'll look at Python, we'll look at Java, and we'll see what we have. So in Python, for the for loop, that is, right, we can introduce this I variable that we know of. I is less than some number, and that some number represents how many times we're actually going to print, right? So we can say hi, and then of course you'll see that if I print this out, I'll get 5 highs. And maybe I have, well, I guess we'll leave it at that. In Python, we have for, again, you can write I for I in range, or for k in range, for I in range. And then here you actually you write the number that how many times you want to print. So if I said 10 here, and I said, hi, I'm going to change what I have in Java to 10, just so that we're on the same page here. So I can print out, 10 highs here, and I can print out 10 highs here, and we're all fine. So the range function actually acts as the I in this case, because it produces numbers 0 through whichever, 0 through wherever, through what you've mentioned here, -1, of course, because we're offset by, it starts from 0. This range function will also produce numbers starting from 0 and do the incrementing for you and assign that to I. So there's a lot encapsulated within this for loop here, but your task, your primary task, is just to know that, or all you really need to know is that this for loop here, it basically, whatever number you put in that range, it will essentially produce. Now, that's essentially the bare basic for the for loop. A while loop basically functions in Java, at least, if we look at the while. So int x is equal to 5, and we'll have to have a semicolon. While x is less than 10, we'll basically continue doing something, right? So system.out.println, and of course it's less than 10, so we'll print out less than, and we'll increment x by 1. So this is actually an increment operator where we can add 1 to x every time that line's executed. And we can do the same thing in Python, right? We'll say while we'll introduce x as a variable. We'll say while x is greater than 10. Again, we don't need those parentheses. We could have them if we want, but we don't need to. So while x is less than 10, we'll print out less than, much in the same way we did with Java, and we'll essentially do x plus plus. And you'll see, so x plus plus doesn't seem to be a supported part of Python. Which we actually have to do is do x equals x plus 1, and that's essentially what we were trying to accomplish here with x plus plus. We were actually doing x equals x plus 1 in a shorter way. And you'll see that we get less than here for in the same amount that we get less than on the left side. And so that's really the primary idea, right? And of course, we could have done this in Java as well. This would have been a supported function, or it's a supported piece of functionality that you can do x equals x plus 1. It's just that Python offers the added flexibility of just doing x plus plus for adding 1 to a number. So this is an increment operator. It adds 1 to the number, but we actually have to do that manually in Java. There is no do while loop in Python, so you don't necessarily have to worry. But you likely already know how that do while operation works in the context of Java. So I'll save you the trouble here and just say that we're fine for now with Python. So that's the main idea behind loops. And I briefly want to cover one of the most foundational data structures that we have in Java, the first being an array. In Java, you actually have to declare int, and then you have notation that basically introduces that you're actually going to have an array. You can name your array, and you have to set it equal to this new keyword. Then you have to repeat what you repeated before, int brackets, except this time you put in a size. And in order to, so that's one way of declaring it, right? And of course, I could have done that like this, where I broke this declaration up into 2, and yet I still have the same idea. There's a shorthand way of doing this, right? You could say int arr, and you can actually just start declaring them. You could say 5 to 4 and 1, and then again, this would work fine. In Python, you can basically just say, hey, my list, and you can declare it this way, right? Where this is all it takes, right? There's no conception of there being a capacity on the size or how big you have to. You don't have to pre-declare what your size should be for the array. You can see here, every time we declared the array, we had to declare what the size was, right? That's characteristic of Python, static memory allocation in Python or not Python, but rather Java. In Python, we could just say the name of the list we want, and then just include these 2 brackets, and that in itself is sufficient. It's just that is our array. And we can, just in the same way here, so this is just declaring an array, right? Just in the same way here, I've assigned values before actually, finishing that declaration, as I mentioned before. I can assign values here as well, and then, I'm in good shape. The difference is that with Python, if I do my list, if I just print the name of the array that I assigned, and I do that for Java as well, you can see that I'm not in good shape, right? So I print this out, I get the memory location of the array, but in Python, it's allowed. In Python, it's fine. I can do 5, 2, 1, 5, right? That's fine. But I can't do that in Java. I cannot do that in Java. And so that's really the core idea, is that not everything works in the same way. Python is more flexible, right? If you want to print an array, you can. In Java, I'll likely have to introduce a for loop here and actually do all this, just a basic array traversal. If you don't know what that is, I encourage you to look that up. But I'll have to print out each element of the array at once, and then print things out, right? Much in that way. I'll remove that just so that the memory location is not getting in the way. But here I have 5, 2, 1, 5, right? And so that's really the idea behind that process. Now, in terms of actually iterating through the array, so you know that in Java, how I iterated through the array was I said, okay, well, I basically iterated for array.length times. And since I is starting at 0, you know, we in an array we have 0, 1, 2, 3. You know, let's say for 3 elements or 4 elements, let's say 4 elements, the index is going to start from 0, 1, 2, 3. So I should be 1 less than the actual length of the array. In this case, the length of the array is 4, but 0, 1, 2, 3. So I is 1 less than the array length. So this works for us. And again, I encourage you to explore the implications of how an array traversal works. If you need a more in-depth understanding of that, it's not really the purpose of this video, but as far as Python is concerned, you can iterate through the array. So I can create a variable called x, and if I do length of the name of the list that I'm concerned about, in my case, it's called my list, I can actually print out that list, or that variable rather, and get the value 4. So the length of my list here is 4, and I can do that in Java too, where I basically just access the length attribute of the array. So you can see that there's a parallel to draw here, that the length attribute for the array gives me the size of the array, which in this case is 4. That was the first print statement, and here I get 4. So the parallel in Python is to do length len, and in brackets specify the array you want. In Java, it's clear that we can just basically just say use the name of your array dot length and then print that out. For actually iterating through, you can say for I or for k in range for the length. So you actually put the length here of your array. In this case, it's my list. And again, I could have simply stored length of my list in that x variable and then just iterated x times. The purpose is really just to touch each slot in the array, and then I could just do print. So you say print and then the name of your list, and then you introduce the brackets, and then you actually do k, so that as k changes from 0, 1, 2, and 3, and so forth, you actually change which element you're accessing in the array. And so here I get all the elements that I'm concerned about, and of course here I get all the elements I'm concerned about as well. So that's really the equivalent, not too much of a shortening from moving from Java to Python, but still relevant enough and short enough and concise enough for it to be somewhat of an optimization, right, in terms of syntactical ease. But this is essentially the parallel that we have here between array traversals. I could sort of make this a slightly more complicated. I could say, well, if any given element in the array, which is denoted by array of I, modulus 2 is equal to 0. Modulus is an operator in Java that basically returns the remainder, or will calculate the remainder. So if the remainder of a number is 0, I know it's even. I could say, let's say I can say, found an even number, right? So found even, I can say. And you can see that this would work just fine. I get 2 found evens for 2 numbers, 2 and 4, and I can basically replicate what I have here. I can say if my list of k is equal to, or modulus 2. Again, modulus is going to work here. Modulus 2 is equal to 0. Then I can essentially do print found even, right? And in our case here, I get 1 found even because I really only have 1 even number. But that is nonetheless a overview of the array data structure, which is commonly referred to as one of the most fundamental data structures, and onwards from there. I'm going to take a brief look at methods in Python and Java. As you know, in Java, we tend to modularize our code so that we can essentially segment operations or logic into these little modules. That's why they call it modularization, into these little functions, we call them. So let's say if I I could create an add function here. So I start in Java, at least, by mentioning what the access modifier is. I write the name of the method. In this case, I can say it's add, or the return type in this case is going to be an integer. I can say add, and then I can pass in two variables, x and y. Then I can essentially store the sum of x plus y in a variable, and then return that sum. So this add is a function in itself, which is independent, and I can call on it. I can say, okay, well, int sum, I'll call it sum, it will store the result of calling this add function. And of course, we know that if it's not attached, if your function is not attached to an object, it has to have the static keyword associated with it. So I'm going to say add, and I'll pass in two numbers, 5 and 2, and then I'll go ahead and print out. What that sum is, right? So if I do that here, you see I get 7, right? And 7 is my response. So I basically called this add method in my main method, and I basically used it by passing in two things, and I printed out the result. How do we do this in Python? The cardinal rule in Python is that all your methods here, so in Java, you can see that we have our methods declared at the bottom. Python reverses that pattern and has us declare them at the top. So in Python, we actually have to say def. Def is our equivalent here. Def, which stands for like sort of defining a function or a definition of a function. We write the names. There's no access modifier involved. There's no static. There's no return type. Again, much in the same way it inferred what the return type, what the variable data type would be once you assign a variable, a data type or a piece of data, it would infer what that data type is. Same thing here. It's basically just going to infer what the return type is. So I can just say add and then, num1, num2, and then semicolon, right? Much in the same way if statements function. And then I can just say, result equals num1 plus num2, and then I can just say return the result. And naturally, then I can say, okay, well, I'll have a result variable down here, or maybe I'll call this sum, much in the same way I did in Java. And I'll basically just do add, and I can basically just do 4 and 2 and print out sum, right? And in this case, I get 6. Now, I could have just returned, right? I could have just returned num1 plus num2. I could have just done that. And of course, I could have just printed out add instead of, making sort of a method call, right? I could have just printed out add. And I could have done much in the same thing that I did in Python. I could have also done that in Java. But nonetheless, that sort of encapsulates the syntax for methods in Python. Now, if you wanted to, you actually have the option to be a little more specific in Python. So Python 3 introduces something that is slightly different from this version of Python, where you don't have to specify anything. What you can do in the parameters, at least, is you can say, okay, well, I'm going to have a variable called num1, and that's going to be of type int. And then I'm going to have a variable called num2. That too is going to be of type int. And then this method is going to return a variable with type int, right? So you've sort of done this thing that's very Java-y, where, Java sort of says, okay, specify your return type, specify the type of variable that you input into the argument or the parameter section. So, you can see Python sort of following that pattern, and it's followed that pattern in a way where it made you it didn't make you, but it gave you the option to, if you wanted to, you could specify the data type in the parameter parts of it, and you can even specify the return type, right? And all of this code will still run just fine. I'll sort of change the numbers here just so you can see that, but. You can see I have 8, right? So 5 plus 3. So this is sort of a different option in Python that you have. If you wanted to be specific, you could essentially specify your return type and specify your data types. You can't necessarily do this in, when you're doing, you can't do this when declaring a data type or when declaring a variable. You don't have the option to specify what it is. Let's suppose this, I'll show you how to return, let's say true and false verdicts, because that sometimes becomes important. So maybe I'll create another method here called judge, right? So judge is essentially going to return true or false, depending on whether my number is greater than 10. In this case, my number is going to be the sum, right? So I'll go ahead and say, okay, well, this is going to be sum, I'll call it random sum. And that is essentially going to be of type int. And what I want to return is a Boolean. So instead of actually listing out Boolean, you just write bool, and then of course your iconic semicolon. Not semicolon, but just colon. I may have been calling that semicolon instead, but just colon. And then you can say, well, hey, if the random sum is greater than 10, return true. Otherwise return false, right? And so and again, remember what false in Python, at least, false has to be capitalized. And once you do 10, or once you add your two numbers, you can print out the verdict. You can print out the verdict of doing judge sum, and you can pass in what you really want to pass in is the result of doing the add function, num1 and num2. And then once you do that, you can essentially pass in result. And then once that's all settled, you can says that num1 is not defined. So let's see here, num1, num2, if the random sum is greater than 10, return true, otherwise return the result. So yeah, num1 and num2 is obviously not defined. I actually have to, these are two numbers that I have to put in. And you can see that I get false, and that false verdict is because my random sum is not greater than 10. If 4 plus 2 is 6. Now, whenever you do this, whenever you have this structure of judging whether something is true or false, and that's the only thing you're doing, instead of doing this return true if it's not, right? If return true if it's true, false if it isn't, you can just say, you can just return the condition itself. And of course, we would remove that semicolon, and you can see we still have the same result. And I'll bump this up to 10 so that you can see what happens much in the opposite case. But that is essentially the idea with methods. We covered data types, we covered conditionals, we covered loops, and we covered methods. And that in itself, in relation to being able to get a working knowledge of Python in terms of its syntactic details, should be sufficient for you to sort of look more into it. Now that we have our working knowledge in Python, let's do a few problems. So I'm imagining a program where we ask the user for whether they want to buy a mango, an apple, or an orange, and based on that, we calculate their cost. And we can essentially continue asking them, and then that cost will keep aggregating as we move. So I could basically say, I could say, well, okay, I got to store their input, right? So I'll give them an option. I'll say, okay, well, this is your option. And I'm not going to do int anymore, right? I'm just going to write down what it is. And I'll say, okay, well, input, what fruit do you want to buy, right? So what fruit do you want to buy? And the idea here might be, well, okay, so they'll give me an option, and I'll have to basically say, one for mango, two for apples, and 3 for oranges. And by this time, of course, they're going to be asking me of an int, and so I basically introduce an int typecast. And by this time, I have an integer for the option, and I'll basically have conditionals, right? I'll say if that option is equal to 1, then maybe I'll take a variable called their total cost, right? So I'll say total cost, and I'll start that at being 0, and maybe I want to have it be a decimal instead. So I'll do 0.0, and I'll say, okay, well, their total cost will be whatever their total cost was before. And then that is essentially equated to whatever their total cost is before, plus, let's say it's 50 cents, right? And we might want to take a slightly different approach. Maybe we want to put this in a method, right? So we'll calculate what their option is, right? And they might not necessarily have to give us anything in return, but let's go ahead and just calculate what their option is. So we can put this option stuff in the method, right? So we'll call option, and that will do it for us. And then once they ask what the option is, we'll say, well, if that option is equal to 1, and let's say that we receive their their total cost, and we'll essentially return a total cost after we're done with it. So if that option is equal to 1, we'll take their total cost and set it equal to what the total cost was before, plus let's say, it's 50 cents, right? And else if, and again, I'm going to do elif, elif option is equal to 2. Their total cost will equal what the total cost was before, plus let's say 0.30 cents. And then finally, if I'll say elif again, if their option is essentially equal to 3, I'll go ahead and take their total cost and equate it to what that was before, plus let's say 20 cents. I'm going to return their total cost that is new to them after having so we have a total cost variable outside, right? That starts off at 0.0, or we'll call this, we'll just say it's cost, right? I don't want to get you confused with different names. And we'll just say cost is equal to 0.0, and we'll go ahead and do, cost is equal to 0.0, and we'll call option, and option will basically trigger total cost, right? And it should have total cost in it as an argument, but really it'll just be cost for now. And so by the time we trigger option, so if I do this here, it says what fruit do I want to buy? I put in an option in, it doesn't really do anything, right? So your cost is actually going to be the result. So this is sort of your new cost, right? Your new cost is the well, get it for now. That's all right.